Next is the design of tank with tubes. This topic is not included in the syllabus, then also we need to study its derivation as well as the problem. The problem is very interesting, it's very simple also. So normally tubes are used in the transformer to reduce the temperature rise in the tank. And also if the tubes are provided, the conduction is improved by 35%. So moving to the derivation, the dissipating surface of tank BST. So this will dissipate 6 plus 6.5 ST, that is dissipation due to radiant and convection. This 6 plus 6.5 is obtained experiment. It is a standard value. Okay, don't confuse with it or think too much into it. So it's just a standard value, 6 plus 6.5. Okay, so 12.5 ST is the total heat dissipation. Let the area of tube is X into ST. Loss dissipated by tubes by convection is equal to 1.35 into 6.5 into X into ST. So 1.35 means if we are providing these tubes, the conduction is improved by 35%. That is 1.35 times. Okay. So therefore the total loss dissipated by tank and walls and tube is this 12.5 ST plus 8.8 XT. Okay. Total area of tank walls and tube is ST plus XST. Okay. Now the loss dissipated is equal to this divided by this. So we will get as 12.5 plus 8.8 x by x plus 1. Okay, we have to just by heart this value only and this step only. Okay, so temperature rise with the tube is theta is equal to Pi plus Pc by St 12.5 plus 8.8x. So this is iron loss and this is copper loss. So from here we will get the value of x, and total area of tube is x into St is equal to 1 by this value. Now the area of each tube is equal to pi dt into LT. Hence number of tubes NT is equal to, this is the equation. So just we need to go through the derivation. For the problem we just need to know basic term like total heat dissipation. Okay, there's no need to by heart this equation. And also for the competitive exam we need to by heart this table, this voltage ratings and also the clearance level. This is very much important. So for the gate exam and also we need to by heart this table. That's all. So moving on to the transformer tank 2 problems. This is the basic problem. A 250 kVA 6600 bar 400 volt 3-phase core type transformer has a total loss of 4800 watts at full load. The transformer tank is 1.25 meter in height and 1 meter into 0.5 meter in plan. Design a suitable scheme for tubes if the average temperature rise is to be limited to 35 degrees Celsius. The diameter of tube is 50 mm and are spaced 75 mm for each other. So in the question, if the tube's diameter is not given, we can assume it as 50 mm and also the space of the tube is normally placed 75 mm each. If it's not given, we can assume as 50 mm and 75 mm space. Okay. The average height of the tube is 1.05 meter and specific heat dissipation due to radiation convection is 6 and 6.5 watts per meter square degree Celsius. And also assume that the conduction is improved by 35% due to provision of tank. So this we need to know. Sometimes it won't be given in question. Okay. So This consider this as a transformer tank. So the height is given as 1.25 and 1 meter into 0.5 meter in plan. Okay, so first we are going to find the area of the plain tank, that is ST, that is side walls only. Okay, so the area is 1.25 into 1 meter plus this 1.25 into 1 meter, then plus this side 1.25 into zero point 0.5 and also plus 1.25 into 0.5. That is the total area. Okay, don't get confused. So the total area of plain tank is given by, that is 1.25 into 1 meter plus this 1.25 into 1 meter plus this side 1.25 into 0.5 plus this side 1.25 into 0.5. Okay, let the tube area be x into st, therefore the total dissipating surface is st plus x into st. Okay, that is the total dissipated surface will be through the plain tank and also the tube area, that is st plus x into st. Now the specific heat dissipation is lambda, therefore theta is equal to q by s lambda. From here we will get the value of specific heat dissipation lambda. In the question, q is given as 4800 and also theta is given as 35 and s is 3.75 into 1 plus x, this value. Okay, so we will get equation number 1. Now we know the total loss dissipated by tank wall and tube is 12.85 plus 8.85 x into st. Okay, that therefore the total dissipated is this value. Now the loss dissipated is equal to total loss dissipated by area. So we will get equation number 2. So equating equation 1 and equation 2, we will get the value of x. Okay. Now the area of the tube is x into st. Okay, we will get the value of area of the tube. Now the wall area of each tube is pi dt lt. Okay. So in the question is given as diameter of the tube is 50 and the length of the tube or height of the tube is 1.05. So don't get confused with the height of the tube and height of the tank. Okay, height of the tube is given as 1.05. See, the height of the tube is given as 1.05. Don't get confused with the tank height. Okay. So we got the number of tubes as area of tube divided by wall area of each tube. So we got the number of tube as 61.8. So fractional is not possible. Therefore, we approximate the value to 62. Now our aim is to place this 62 tube around the plain tank. Okay, if consider this as a plain tank, then we have to place these 62 tubes on all sides of the tank. Okay. For that, the size, the length is given as 1000 mm and width is given, I mean the breadth is given as 500 mm. See in question, the length is 1 meter and the breadth is 0.5 meter. So we changed like to millimeter, that is 1000 millimeter and 500 millimeter. We need to place the tubes over all these 4 sides of the tank. Okay, so first of all we need to draw a rectangle tank like this. Okay, so this is 1000 mm. Okay, and this is 500 mm. We need to place all the tubes over here on the 4 sides. So before placing these 4 tubes, first we need to leave the clearance level on the each side. Okay, and here we need to place the tubes. So before placing the tubes, we need to know how many tubes should be placed in the length and also in the breadth wise. So in the length wise, it is 1000 divided by the space of each tube, that is 75 mm, that is we got as 13. So since we are leaving the clearance level, just reduce 1 from the main value, that is we need to place the 12. And also breadth wise 500 by 75 gives 6 tubes. So leaving the clearance value, we need to place only 5 tubes here. Okay, so what we have to do is we need to place 62 tubes. Okay, so we'll be drawing this rectangular tank, we'll be leaving the clearance level. Okay, now just see, lengthwise we need to place 12. So 1 2 3 4 5, like that 12 tubes we will be placing, like here. So here we will place 12 tubes. Okay, and between these two we will place again another one. So like that we will be placing, and also here we will be placing 5 tubes. In between we will place another tube. Like that we will be placing here 12 tubes. In between here we will place like that. It will goes like that. Okay, so finally see here 1 2 3 4 5 6 7 8 9 11 12, then 13 14 15 16 17 18 19 20 21 22. Okay, 22 23 23 here this side, and also here 23, that is 46. And here 1 2 3 4 5 6 7 8 9, like that's 18 tubes here. So fine, totally we got 64 tubes are placed. So the total possible number of tubes is 64. So this is how we need to do this problem.